My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 435. In this lecture, we will try to understand Fourier decomposition or Fourier transformation. So, very popular way or popular method to represent time series data is using something called as Fourier decomposition or Fourier transform. The idea of Fourier decomposition or Fourier transform have been studied extensively in physics, in applied mathematics, also in electronics and communication engineering. This is very powerful idea, very powerful mathematical concept that is extensively used and studied in the whole of data science, even in computer science. It is used in concepts like image compression, signal compression. Mostly people have studied signal processing as a subject. If you have studied it, you would have encountered Fourier transform or Fourier methods in signal processing. Lots of students who study engineering would have encountered this in one of your mathematics subjects, one of your engineering mathematics subjects. As usual, since we are not using for long time, most people would have forgotten what is Fourier decomposition. Before we go and understand what is Fourier decomposition, we have to understand some simple terminology. You have to understand what is frequency, what is the meaning of frequency, what is the meaning of amplitude, what is the meaning of amplitude of wave, what is the phase of the wave. Let's understand very simple terms, and we go back to Wikipedia page as a source of knowledge. Imagine this is sine wave, isn't it? Imagine this is a sine wave. This is like sine wave. Given any wave for that matter, let's take sine wave for simplicity. I can compute these things. Amplitude is nothing but amplitude. Amplitude is the height, isn't it? What is the amplitude? Amplitude is the height. Remember, this is the wave and this is the time axis. Where is the time axis? Just see, this is your time axis, isn't it? This is time axis. This is time axis. I can say amplitude is basically, what is this? This is amplitude, isn't it? Amplitude is basically the height of the wave. The height, what is the height? This is the height, isn't it? Amplitude is basically the height of the wave. This height is called amplitude, isn't it? This particular height is called amplitude. Similarly, there is something called time period of the wave. There is something like time period, isn't it? Time period of the wave, or period of the wave, which is the time it takes. Time it takes. What is time period? Time it takes to do one oscillation. What is oscillation here? Which is you start here. Just see, what is this? Oscillation means what? You start here, isn't it? And goes up like this here. This is one oscillation actually. This is known as one oscillation, isn't it? What does it mean? What does it mean? You are starting here and goes up. Just see here, your air goes up and again you comes down and again gets minimum. Again you are gets minimum, and then it comes up. Just see, then it comes up. This thing is known as, this particular thing, this is known as one oscillation, and it time, isn't it? So this is called a cycle. This particular portion, this is known as a cycle, isn't it? Or one oscillation. This is called one oscillation. Which one? This entire thing is called one oscillation, because your sine wave repeat itself, isn't it? If you observe sine wave, it repeats itself. So time it takes. So time it takes to complete one oscillation is called the time period. Often it written as capital T. So the next important concept is frequency. We have seen what is amplitude. Amplitude is basically this height, isn't it? This height is amplitude. So time period are often called period time it takes for a wave to make one oscillation. What about frequency? Frequency is nothing but frequency equal to 1 by time period, or time period equal to 1 by frequency. So for example, if wave makes one oscillation, let me say if wave makes one oscillation for every second, let's assume this is my time axis, isn't it? What is my time axis? This is my time axis. This axis is time. If it makes one oscillation per second, if it makes one oscillation per second, then it is said to have 1 hertz of frequency, isn't it? Frequency is measured in hertz. Suppose if it makes two oscillations per second, then we say that it has 2 hertz frequency. That's what frequency means. Frequency is very, very important concept, especially for repeating waves. For example, suppose you have your heart rate. We know that if you take to any doctor, or even if you Google search for it, human heart rate is between 60 to 100 beats per minute. When heart beats, then it contracts and expands. You can think beats as oscillations. It oscillates the heart. The heart compresses and then expands. A typical human heart makes 60 to 100 oscillations per minute, which is equivalent to 1 to 1.6 beats per second. Beats or oscillations per second, which is equivalent to 1 hertz to 1.6 hertz. And we know this because it's a physical phenomena. It's a repeating phenomena that happens in all of our hearts. Your heart contracts and expands. So human hearts, if you go to any doctor, or even if you Google search for it, you quickly notice that they beat 1 hertz to 1.6 hertz. And this information is very, 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 very important, because imagine if human heart is beating, let's say 150 beats per minute. If you assume if it beats 150 beats per minute, what it says, just see, 150 beats per minute or 30 beats per minute. 150 beats per minute, or let's say if it beats 30 beats per minute, the person whose heart is beating at 30 beats per minute or 150 beats per minute is at risk. If heart is beating a lot, probably he is either exercising or there is some complications. If it is beating too low, probably he is sleeping or there is something wrong. By looking at the frequency of your heartbeat, doctors also can diagnose some type of illness. So frequency is very, very important idea. So amplitude, time period and frequency are 3 basic concepts of any oscillating sine wave. There is other concept called phase of a wave. Let's try to understand phase of a wave again from the Wikipedia article. This is the article for phase shift. So if you look at the red line here, if you look at the red line, this at time this is time equal 0, at t equal 0, it has got value 0, isn't it? Red line has got value 0. We say that red sine wave has phase of, what is the phase of red sine wave? Red sine wave has a phase of 0. If you take blue wave, its 0 is somewhere, this blue wave is 0 at somewhere here. Just see this. What about blue wave? This is 0 here, isn't it? If you take blue wave, it is 0 at this particular point, at somewhere here. At t equal 0, blue wave has got some value. Just see, blue wave is not at 0. We say that the difference here is called phase. What is this difference? This particular difference can be treated as phase for for this difference. This difference, it is the phase of the blue wave. Phase is also important. The most important in all of them would be frequency. Frequency is something very, very fundamental, especially for things when you see repeating behavior. Repeating behavior occurs in heart rate. It also occurs in e-commerce. It also occurs in e-commerce sales. If you think about it, because there is a daily pattern of sales. Because if you look at it at midnight, this is at midnight, at time 0, at midnight, at time 0. Let me say, yes, just see this one at time 0, at midnight, at time 0, as we at midnight, this is at time 0. As we go to, just if you observe this one here, almost sales are 0, almost 0, almost sales, almost 0, sales are 0. Here you have sales. This is the, what is this? This is day hours. This is day hours. You have sales, isn't it? Day hours. And this is again night hours. This is again night hours. Isn't it? 2 p.m. something, probably sales are very low. Your sales falls almost to 0. During the day hours your sales increase, and during the night hour your sales again drop. And this is time. This is an x-axis. Again, you must understand an x-axis again time. So for e-commerce sales, for any retail sales, your daily pattern is like midnight, maybe at 3 a.m. like nobody is supposed shopping online, isn't it? Nobody shopping online at 3 a.m. or midnight time. During peak hours, morning hours or afternoon hours or after office hours, lot of people will be shopping. So there is daily pattern here. There is some daily pattern for retail stores. There is some daily pattern for e-commerce sales, because there is a daily frequency at which this pattern can be observed. There is also not only daily pattern, there is also weekly pattern in sales, because during weekends people may be celebrating, may be going out on activity. What will we notice is during the weekdays, if you have nice good sales during weekend, just see during weekends, just let me consider like this is during weekends, this is during weekdays, isn't it? If you have nice good sales during weekends, it dips again, it goes up, and it goes up again, and during weekends it again dips. It goes up and it dips again. In weekdays it goes up, and weekends it dips again. Weekdays it goes up, isn't it? We start seeing the waves like this. This is the I can say this is the weekdays sales. This is the weekdays, and I can say during the weekends, typically this is during weekends. During weekends, typically, especially for e-commerce sites, you tend to see your sales dip, because people are probably go outside or visiting their family, trekking or something like that. Again, it depends on country to country. In some countries where weekend sales may be more than weekday sales. I think that might be true in some cases like India, where I see a lot of people going to malls and going to even online e-commerce sites during the weekends, because that's the only time they get. So there is a daily pattern and there is a weekly pattern. There is also something like annual pattern, because if you are looking at, especially in Western societies, during Christmas time, during Christmas or holiday season, your holiday season sales for a company would be significantly more than non-holiday. So even in e-commerce sales, just like an heart rate, your heart rate for every minute or for every second, your heart goes up and comes down. Similarly, in e-commerce sales, completely different from heart rate. you still see repeating patterns. So wherever you see repeating pattern, looking at frequency is a very interesting idea. Now let's go and understand what is Fourier transform. I will discuss what is Fourier transform in my next lecture, that is in lecture number 436. Thank you very much.